So previously we learned about the pressure increase, disturbance pressure increase, and the pressure decrease, right? So beside the pressure, so actually under the pressure we have another two side is add the inert gas at constant volume. So this is the first condition. So how about the equilibrium position when you add the inert gas at constant volume? So now you look at this picture. So this equilibrium contains two gas. So pressure A, partial pressure A, and partial pressure B. So how we calculate the P total? P total equals to PA plus PB. Let's say I assume PA is a 5 atm, PB also 5 atm. That means your P total equals to 10 atm. So another meaning is to calculate the PA is NA over V, mole over volume times RT, and the PB is MB over volume times RT. Okay, now how about the condition at constant volume? Constant volume meaning that volume no change, volume tetap. So volume no change, that means that after you add the inert gas PA plus PB plus P neon, example, okay, now your P total now is different. So include the PA, PB, and P neon. Okay, volume no change. You can see the glass, the box is the same size. So volume constant. Okay, now how about this? The condition say volume no change, volume constant. So when this volume constant, meaning that the partial pressure for PB is a constant. The volume for the A is a constant. That means that the partial pressure A also constant. So another meaning, so your PS should be remain 5 atm. So PB also 5 atm, but neon gas maybe 2 atm. The total is a 12 atm. Okay, from this observation, you can see the partial pressure of the each gas is a constant. Mole and volume of gas also constant, but the total pressure will increase. Okay, now for this case, right, we just look at the partial pressure each gas. The partial pressure for the gas is constant. That means that they not influence the equilibrium position. So equilibrium position will shift to where? No, equilibrium position will not affected. Will not affect. Yeah, so this is a conclusion where the inert gas at constant volume, because partial pressure is gas is constant, because the volume is a constant, they not influence the partial pressure. Once the partial pressure constant, equilibrium position will not affected. Now this is a part B, where is add the inert gas at constant pressure, means you remain the pressure, means even if you add the inert gas, right, the P total is constant. So this is a equilibrium PA plus PB. P total equals to PA plus PB. So we assume the PA equals to 5 atm, 5 atm, total is a P 10 atm. So as you know how to calculate the 5 atm is mole over volume A times RT and mole over volume B times RT, right? Okay, now so this is a case where is you add the inert gas. As you know, right? When you add the inert gas, you increase the frequency collide with the wall. So you will cause the pressure increase. So how we remain the constant of pressure? You must increase the volume of a glass or volume of a container. So to remain the constant pressure. So P total equals to PA plus PB plus P neon gas. So just now I said constant pressure, meaning that your P total equals to 10 atm remain. So same like the equilibrium and the after. So P total remain 10 atm, meaning that how about your PA? How about your pressure for A? Just now is a 5 atm, meaning that now the PA should be decreased, maybe 4 and maybe the neon gas equals to 2. So this is a condition constant pressure where the ATM before and after is the same after you add the inert gas. Alright class, now I want to reduce the PA. PA just now equals to 5 atm. Now I want to reduce become APA now is a 4 atm. Okay, now we go back to this equation. How I going to reduce the PA equals to 4 atm? The solution is we increase the volume of the volume. So once I increase the volume, the pressure for the partial pressure will decrease. So conclusion, you can see the partial pressure of each gas was decreased. More of volume of a gas is the volume of gas is increased, the more is remain. Okay, now total pressure is a constant, right? So now, just now I tell you to determine the disturbance or not at the inert condition, we'll look at the partial pressure of the gas. So partial pressure of gas is a decrease, meaning that this is a disturbance. So how to reduce the disturbance? We must increase the pressure back. How we increase the pressure? We must shift to the larger more of the gas. So conclusion, equilibrium position will shift to the larger more of gas. So this is a result from the at the inert gas at constant pressure, the equilibrium position will shift to the larger more of the gas.